In this lesson, we're going to continue our study of medians. We're going to look at the next step, a centroid. That's the point of intersection between medians. But before we get there, we'll just review some stuff from the previous lesson. Start with an example. We have a seesaw with its pivot, that's where it turns, at 2, 3, and one end at -2, -3. Can we find the coordinates of the other end? So let's think about a graph, if you will. So P, 2, 3, right there in the middle. We've got another point, A, -2, -3. Where would B, the other end, have to be? Well, if we continued it, it would have to be somewhere up here, right? Now, because P is in the middle, we can use the idea of midpoint. Our midpoint formula was x1 plus x2 over 2 and y1 plus y2 over 2. We know when we have formulas, we can fill stuff in and solve the parts we don't have. We're told the midpoint's at 2, 3. We're told one point is at -2, but we don't know the other x. So let's put it as x. We know one of the y's is -3, but we don't know the other y. When we do this, we actually have two separate equations. We have the x piece, and we have the y piece. If we write them separately, we can see, hopefully, how we can solve these things. Our key there is we can cross multiply. So let's do that. 1 times -2 plus x is -2 plus x. 2 times 2 is 4. So I can add and get my x value. If we do the exact same thing with the next one, we'll get -3 plus y is 6, or y is 6 plus 3, and it's 9. So B, the other endpoint, has to be at 6, 9. Now that's the formula way. Some people like the formulas. Other people like to be able to think. So let's think for a second. To get from A to P is a line, so it must have a slope. We have to go up 6 from -3 to +3, and then right 4 from -2 to +2. Well, that same thing must be true to get to B. Let's go up 6 and right 4. So if we go over 4 from 2, we'll get a value of 6. If we go up 6 from 3, we get a value of 9. And hey, that's the same answer we had. So let's take medians to the next stage. So yesterday we talked about medians, and we talked about them being the lines that join a vertex to an opposite midpoint. We said where they meet is called the centroid. Our objective today is to figure out that centroid. Now, we have 3 medians in every triangle, but I don't need all 3 equations. If I could find the equation of this one, mx plus b, that's the equation of it, and I could find the equation of, let's call this one, the third one will have to meet where the first 2 do. And that's really what I want to find. I want to find the POI of 2 separate equations, the point of intersection of them. So let's give one of these a try. So we're going to have this triangle, vertices of A, B, and C. So first thing, just to get on the right track, let's draw the picture so we can see what's going on here. So we have some axes. We got -3, -1. That's A. We got B at 3 and 5. And we got C at 7, -3. Draw our triangle. And we want to find the equation of the median from A. Part B. Oh, sorry, part A. So let's talk about the median from A. Where does it start? It goes from A to the midpoint of BC. Well, I don't know that yet. So that's the first thing I have to figure out. The midpoint of BC. I know the coordinates of A. They're -3 and -1. Midpoint of BC, that's going to be 3 plus 7 over 2. And 5 plus -3 over 2. So my midpoint of BC will be 10 over 2, 2 over 2, or in other words, 5, 1. So now I can draw it. 5 and 1, right about there, the midpoint of BC. I want to find the equation of that line. So how do I do that? I got to start at A and I got to end up here. Well, to do that, I need to find the equation, the mx plus b. First thing I can do is find my m. So I can do the y minus y, x minus x, give me 2 over 8. Now that's a fraction or a decimal, but it's a nice decimal. And there's nothing wrong with using nice decimals. So I know my slope is 0.25. I can plug that into my equation. That's my slope. To find b, I need to know an x and a y, and I have two choices. I can use point A or point B, because that's where it starts and that's where it ends. Those are points on my line. I'm going to use B because it's got positive numbers. So 1 for y and 5 for x. I'm going to expand my brackets. Sorry. 0.25 times 5 is 1.25. I'm going to rearrange this so I can solve for b. And b is negative 0.25. So in other words, the equation is y equals m, that was 0.25, x plus b, and b is negative 0.25. So that's a little squishy. I'm going to move it and just make it a little bigger here. Okay, there's my median, the one that goes from A. Next part, let's find the median from B. So I know it starts at B. It goes from B, and B is a 0.35, to the midpoint of the opposite side, the midpoint of AC, but I don't know that, so I have to calculate it. Negative 3 plus 7 over 2, that's my x's. Negative 1 plus negative 3 over 2, that's my y's. That's going to give me 4 over 2, and negative 4 over 2, or in other words, 2, negative 2. Okay, I know where it starts, I know where it ends. 2, negative 2, how about there? Draw my line. I want to find its equation. What do I start with? We need a slope. I got to go from here to here. So my slope would be negative 2 minus 5 over 2 minus 3, where it's negative 7 over negative 1, which is 7. Okay, now I got a slope. Y equals mx plus b. To get b, I need a point. I have choices, either that point or this point. I'm going to use the 3, 5 point because it's nice whole numbers and they're positive. I'm going to solve for b. 3 times 7 is 21. Rearrange it. B is negative 16. So my equation is 7x minus 16. So I got myself a second equation, my next median. What do I got left? The coordinates of the centroid. The centroid is where these two things meet. Right here, this POI. The POI between two different equations. That's what we learned about all last unit. We have the red equation, that's this one. We have the blue equation, that's the other median. Where do they meet? Well, they meet where they're equal. So I can set my two equations equal to each other. And if I do that and I solve it, I'll find my POI. So let's rearrange. Numbers on one side, letters on the other. We'll get 6.75x equals 15.75. Use our calculators for that one. Get roughly 2.33333 repeating. Forever and ever and ever. Here's my x. How do we get the y? We take one of the equations that we know. So I have to, I'm going to use the blue one, the 7x minus 16 one. I know that equation. But I also know what x is. X has to be 2.333333 repeating. If I put that in my calculator, I can calculate the y value as 0.33333 repeating, never ending. So where is that centroid? That centroid, that point of intersection, is at 2.33 repeating and 0.333 repeating. Which, if I look at my graph, 2 1/3, that's over to the right a little bit, and up 1/3, that actually looks pretty accurate in relation to my graph. I'm on the right track. Now, that's a lot of work. It's lots of steps. It's easy to make a simple mistake there. So, there's a bit of a shortcut. Not a shortcut for the equations of the lines, but a shortcut for how to find where they meet, the centroid. And what we can do is we can actually take the values, the endpoints, A, B, and C, and think of them as, well, I want to find the average of these points. Where do they all meet in the middle? So if I were to add up all the x's and divide by 3, and add up all the y's and divide by 3, it turns out that's the exact same points as the centroid. Okay, so here's our big idea. x1 plus x2 plus x3 divided by 3. Same thing for the y's, divided by 3. And we could check it for the last one, just to prove it. Okay, what were our coordinates? If we go back for a second, we had A, -3, -1. We had B, sorry, 3, 5. And we had C, 7, -3. And we have on our centroid was not negative, 2.3333 and 0.3333. Well, let's see what happens when we use this formula. Call this centroid. If we add up the x's, -3 plus 3 plus 7 divided by 3, add up the y's, -1 plus 5 plus -3 divided by 3, what do we get? We get 7/3 and 1/3. If you change those to decimals, you get this. So that's a much faster way of approaching the centroid. I'd prefer that you guys use that when you find the centroid. It does not shortcut medians though. You still have to be able to find the equations of those things, at least one or two of them. Okay. Just to point out, we might come across this word center of mass. That's another way of saying centroid. Because when you balance a triangle, to perfectly balance it, the mass is all balanced out. It turns out it balances on that center point, the centroid. I'll try one real quick here. Find the center of mass for a triangle with vertices x, y, z. What am I really finding? I'm finding a centroid. So my centroid will be -4 plus 2 plus 6 over 3. That's all my x's. My y's. And what are we going to get? Well, -4 plus 2 plus 6 is 4/3. And 3 plus 9 plus -3, 9/3. Or in other words, 4/3 and 3. And I prefer just leave it as a fraction. Don't worry about writing out 1.33333 because the more exact version is a better version. Okay, no fractions. And as you come across the word centroid or center of mass, shortcut. That's what you're doing. All right, last idea for today. Different kind of application, not a centroid. In fact, we're going to call this one a bisector. A waste management company is planning to build a landfill in a rural area. To balance the impact on the two closest towns, the company wants the landfill to be the same distance from each town. On a coordinate map, the towns are located at A and B. Describe all the possible locations for the landfill. So let's draw this out. What's going on here? We've got a town at A, and A is 1 and 8. Another town at B, and B is 5 and 2. And we want to put a dump between them. But we want to put it in a fair spot. Okay. Fair means it should be equal distance. In other words, the midpoint, right? Well, I can find that pretty easily. The midpoint of AB, we've done this before. There's no tricks here. 1 plus 5, 8 plus 2 will give us 6/2 and 10/2. Or in other words, 3 and 5. That'd be a good spot for that dump. But the question, if we read carefully, says all the possible locations. So what does that really mean? Is there another spot that would be equally fair to put that dump? What if we said if both towns are 10 kilometers from the dump? Maybe 10 kilometers away would be right about here. Or maybe 10 kilometers is right there. Or here, or here, or here, or any of these spots. Well, if I connect all those spots, I think I'm making a line. So if the dump was anywhere along that line, it would be fair for both towns, so the same distance away. I want to find the equation of that line. What do I need for the equation of a line? I need mx plus b. Now the good news is I know a point for sure on this line. I got an x and a y. The only thing I don't have is a slope, an m. We've said that you can find a slope if you know a starting point and an ending point. But unfortunately, I only know one point on this line. So I have to use a different idea. The idea I need to use here is going back to the starting point. The best place we picked from the start was right in the middle of them. So if I were to connect that with the two towns, I form another line. And it's kind of tricky what this blue line is, that it's actually perpendicular to the green line. So by finding something about the blue line, I can actually find something about the green line. If I find the slope of AB, which I can do pretty easy because I got the start and the end, so 2 minus 8, y2 minus y1, and 5 minus 1, I'll get negative 6 over 4. And that's helpful for me because it's perpendicular to my line. So my slope, the green one, I have to flip it over, take the reciprocal, and make it the other sign. In other words, positive. And I can use 4/6 or I could reduce it to 2/3. Either one doesn't really make a difference. So now, for that green line, I know its slope. It's 2/3. And I can solve for b by using the point, the midpoint, that I know. Y is 5, x is 3, solve for b. Okay, use your fraction button or multiply straight across. You get, 6/3. 2 times 3 is 6, 3 times 1 is 3. And you can reduce that even, so 2 plus b. And solve for b. Hey, I figured out the equation of the line that the dump should be placed on. It should be anywhere along the line y equals 2/3 x plus 3. And this line here, we call this a bisector. The reason it's called a bisector is it cuts something in half. It bisects. Sect means cut, bi means in half. So if you actually go back here and think about this, okay, these two things are going to be equal all the time. Have to be equal. Cuts it in half. Okay, that's the end of the lesson. Some homework to try. There's 3 questions. You need to practice medians still, because I still need to be able to make the equation. You can find a centroid using a shortcut, also called the center mass, and you should be able to find the equation of a bisector. That's a new idea.